So remember that as you make your page of notes for tomorrow, you can use anything that you want as a page. You can make anything you want as a page of notes. So that means that you can copy these practice quiz problems into your notes. You can put little reminders into your notes. The big ones that I would put on my notes, the big two things to me would be, number one, don't forget if you multiply or divide by a negative to switch the Pac-Man, right? And then number two is, remember at the end, put the variable on the left side. Unless you're one of those people that can keep it on the right side and get away with it. But I think for most of us, those should be the two big ones. Remembering when to switch the sign and remembering when to write it backwards. So the rest is just basic algebra, knowing how to kill fractions, how to distribute, how to move terms across equal signs or inequality signs in this case. So we'll run through this. There's no way this is going to take all hour. So after that, you can have some time to work on your page of notes, or we can go over some more problems, whatever I can do for you. The goal always is tomorrow when I give the quiz and I take it home and I grade it, that they're A's and B's and maybe a couple C's. You know, we don't want to go through the whole, can I retake it thing? That's what we want to avoid. Right? We want to head forward, keep pressing forward and not have to keep going backwards. So that's the goal. First problem is there. Do I have the right thing up here? Yeah, practice quiz number 2. So I'm going to go ahead and add 1 to both sides. And then I'm going to bring down my negative 3x. I'm going to bring down my sign. And then I'm going to add 1 to 19, and I'm going to get 20 like this. And then this, what we're about to do is a double switch. I do not advise you. This is very, very strong advice. Do not double switch at the same time. So the first switch that's about to occur is when we divide by negative 3. So I'll show my work on this step. So when I divide by negative 3, I have to switch my inequality sign. So I bring my x straight down. I switch my inequality to this one, and then I just leave this side as an improper negative fraction. I would not advise that you also try to switch sides at the same time. It's not a challenge. I'm sure some of you can probably do it just fine. It's just good advice. So now I'm going to switch it backwards, and I'm going to write it correctly as x is greater than negative 20 over 3. All right? And remember, as far as the graph is concerned, don't go all crazy with a bunch of tick marks. Just label the only number that we care about, which is the boundary. Do I color in this circle? No. I do not. And which way will I shade? To the right, because at the end, when I wrote it the correct way, it says x is, to be x, you have to be greater than that boundary number. So we go to the right. Any questions there? 1 down, 9 to go. All right. Let's play a game of Survivor. What that means is we're going to, you're going to raise your hand if you got the first question right. And then after every question, I'm going to ask you if you've gotten every question right to this point. And we're going to see if anyone survives to the end as I got the whole 10 right. So how many of you got problem 1 right? That's dope. All right. So we're in good running here. We got like 20 people. All right. Question 2. I am going to get rid of the 2 first. That's the way I like to do these. And so I'm going to subtract the 2 to the other side, which means I'm going to leave the negative 3/7 of x alone. I'm going to bring the sign down, don't change it, and then I'm going to do 5 minus 2, which is 3. And make sure you didn't put 7 there, okay? That's a rookie mistake. And then I am going to now multiply, and because I feel like it's the right thing to do, when I multiply, I'm not just going to multiply by 7. I think we talked about this yesterday. I'm going to multiply by negative 7. I'm thinking ahead, and I'm thinking I'd rather just switch the sign now instead of worrying about it later. So when I multiply by the negative 7, the negatives cancel each other out, the 7s cancel each other out, and I'm just left with 3x. But I do at this immediate point in time have to switch that sign. So the moment you attack it with a negative like that, whether it's now or in the next step, you have to at some point acknowledge that it's going to flip. And then, of course, on the other side, 3 times negative 7 is negative 21. Good. So I've already switched my sign. Some of you might not have. Some of you might be looking at this. I'm going to write this over here. Some of you might still have this. Negative 3x is still less than or equal to positive 21. So like you and I are headed to the same place. So I'm going to divide by my positive 3 and give myself x is still greater than or equal to negative 7, you see. And if you're that person with the thing I wrote in the middle of the TV up there, if you're that person, then you have to divide by -3. And you get still x is switch the sign. So you see it all comes out in the wash. It's just a matter of when. All right, so again, I'm only going to mark what I care about, and that is my boundary point at -7. Do I color in the circle? I do this time because it's got the equals with it. And it's, again, another greater than, so I'm going to shade to the right. Okay, show of hands, how many of us are still perfect? The numbers have dwindled a little. Okay, we lost a couple there. Let's head on down. So for this next question, there's no trickery here. I'm just going to see who's got their poop in a group. Like, who knows how to get the x's on one side and the numbers on the other. And again, the biggest mistake you could make here would be even to let -8x cross your mind. That's just, you're not ready to stop showing work if that's your thought. I do want to get that -x over to his buddy. To get him there, I have to add x, and so that's going to turn this into a -6x. Right? We comfortable with that? Now, while I'm doing this, I'm thinking to myself that the 5 can't be there anymore because the x's have taken over. And so I'm going to subtract the 5 across also to the other side. So I'm going to leave my inequality sign facing the same way, but I'm going to, again, don't think 18, think 13 minus 5, because we had to move him, which is 8. Got it? And now we do have to switch our sign because inevitably here we have to divide by a negative. And so when I divide by -6, I'm going to show my work on this one just because it's going to be one of those that we know is going to be a fraction. So I want to see what the fraction looks like. So I have x. I have to switch my sign, and I just get a fraction that is negative. And don't lose points by not reducing fractions. Either you should know how to do it, or you should let me show you how your calculator can do it. One of those is a fact. So 8 and 6 can reduce down to 4 and 3. So that is the answer that will not lose you any points there. Right? So again, mark only what you want. You don't have to put all the numbers that surround it. Just mark the boundary, which in this case is -4/3. I do color in the circle, and it's another, that's 3 in a row, I believe, greater than, and so I'm going to go to the right. Are we perfect still? 3 for 3? 2, 3, 4, 5, 6, 17 perfect still. I'm going to write that down. 17 are still survivors. Good job. All right, on to problem number 4. Same idea, just separation of x's and numbers. It's just like Algebra 101. So like my prime first semester objective is, can I get these kids to understand how to throw the x's on one side and the numbers on the other? We get that, man, we're winning. So I'm going to take the 12x and I'm going to subtract it. Right? So I'm going to take the 9x over here and I'm going to subtract the 12x from him, giving myself -3x. And I say to you the same thing I always will, and that is if the x's take over one side, which they have, then the -10 is no longer welcome there. So we have to get rid of him by adding 10. My sign does not change. It will only change when you multiply or divide, right, by a negative. So when I add 10 across, what is -31 plus 10? -21. I find myself again dividing by a negative. I'm not scared. When I divide by -3 this time, I get x is, switch the sign, less than, and I don't need to show a lot of work on this. What's 21 divided by 3? 7. And notice I didn't say -21 divided by -3 because I know they're going to come out positive anyways. What's the point? So as you type numbers into your calculator throughout the rest of your math career, be aware of whether do I really need to type negatives into a calculator for multiplication and division problems? The answer really is no. Like, you just know going into it if it's going to be positive or negative. So just type in the numbers and you worry about the signs. So finally, we get to graph one to the left. So this one should have a circle at 7 that is not colored in, and it's less than finally. So we go to the less than side, which is over here. How many still alive? 1, 2, 3. Oh, Brandon was slow. 1, 2, 3, 4. 16, we lost 1. Did somebody miss that problem? Looks like it. Okay, so we're down to 16. All right, let's keep going. You guys doing okay so far? All right, good. And then these bottom problems, we still have not introduced fractions into the mix. Fractions won't pop in until the end of the quiz. So this quiz isn't so much about fractions, it's about just your manipulation with inequalities. So I'm going to distribute on the left and the right sides. So I'm not going to mess up. I mean, I say that, I could, but I'm going to try not to. When I distribute 2, I should get 6 x's, and then minus 2 times 1 is 2. Keep your sign the same. And then distribute that negative. You guys ought to be pros at this by now. The 4x becomes a negative 4x, and the minus 18 becomes a plus 18. And here we are set up again to do this thing that we should be experts at by now, this separation. So I'm going to pull my 4x, my negative 4x over to the left. And remember, to move him, I have to do the opposite of what he is. So I add 4x. So I actually wind up over here with 10 x's. And again, same speech. 10x looks at the minus 2 and says, you can't be here anymore. So I add 2 to make him go away. And that gives me, keep the sign the same, 18 plus 2 is 20. Say again? You bet. Divide both sides by 10, and I get x is, keep the sign the same, 20 divided by 10 is 2. So mark it. Do not shade it in. Shade to the left, less than. I'll wait a little bit to do survivor. I'll count again after every 2 problems. How's that? All right, next problem on the right is the same problem again, just a little bit more negative distribution and a little bit more of a test at the end to see, are you a variable on the left kid or a keep the variable positive kid? I think most of you are starting to gravitate towards the heck with it, just move the variables to the left thing, which is solid. So on the left, I should get negative 8x and plus 12. Keep the sign the same. Negative 2x. Change the sign to 34. Sixth verse, same as the first. Got to get your variables on one side. I prefer the left, so I'm going to add 2x to make the negative 2x go away. And when I add 2 x's, whether I show my work or not, I have to know that negative 8 plus 2 is negative 6. So I have negative 6 x's now on the left-hand side. They look at the plus 12 and say, make like a banana and split, right? Get out of here. So we have to get rid of the 12 by subtracting 12. So we have on the right-hand side now 34 minus 12, which is 22. We okay? We see now that this is going to be a fraction. We should be okay with that. We know that 22 isn't going to divide nicely by 6, negative 6, whatever. So answer is fraction incoming. When we divide by the negative, then we have to be aware of switching our inequality sign, because I'm dividing by negative 6. Let me show a little bit of work. I haven't shown much work here in a little bit. So there's me dividing by negative 6, right? And then I just got a little bit of a basic math question here. And again, I wouldn't worry about putting negatives into my calculator. The only time you guys should ever put negatives in your calculator is when you're adding and subtracting. Like if you struggle with adding and subtracting, like I could see typing in like negative 4 plus 11 or something. But like if it's times and divide, just worry about the sign and then do the math. So like I know that a positive divided by a negative is going to be a negative. So my answer is negative. And then rather than write the fraction as 22 over 6, I reduce it down to 11 and 3 like that. Said before, you don't want to lose a point because of not reducing fractions. That's a real ghetto, cheesy way to lose a point. You know, that's just you selling yourself short. So this will be a colored in circle. It's going to happen right at negative 11 over 3. Just mark it, circle it, color it in. It says greater than my final statement, so I'll shade 2. All right, let's take another tally. How many are still perfect? Raise those hands high. I want to be able to count. No lazy hands. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're still at 15. Oh, darn. Good thing this is just a fake quiz, huh? No points lost today. All right, so we're at 15 still alive. Survivor number sits at 15. These are where the numbers sometimes start to drop because the problems get a little bit, there's more stuff you have to do now. So in these top two problems, really, it's not about fraction killing. It's about, like, do you know the order of operations? Do you know how to distribute? Do you know how to combine like terms? So distribution comes first on both sides. And I need you to understand, which I think by now you do, the only math that you do is in that red box and in that purple box. Don't make a rookie mistake and think that the other things have anything to do with this. They have to wait. So the 1 comes down. And then when we distribute -4, what do we get right there? -4x. And what do we get right here? +8. Very good. That's where things can go downhill quickly. So just be careful. Copy your sign down. Copy down your 8x. Remember, he's got nothing to do with anything. And now when we distribute a negative, we get -x and +3. Perfect. And then copy down the -9. Whew, we made it through the first step. Now it's time to combine up our like terms. So on the left-hand side, I do see some like terms. I see a 1 and an 8 that don't have x's, so they can go together. What's 1 + 8? So my left side is 9 minus 4x. Copy down your sign. On the right-hand side, I see some like terms. I see an 8x and a -x. What do they make? No, 7. If you have 8 x's and take away 1 x, you get 7 x's. So we're left with 7 of those. And then I also see a 3 and a -9. What's 3 minus 9? -6. So we've made it now to a point where 2 steps later, we have a problem that looks now just like the third and fourth problems on the quiz. So again, I'm not even going to ask for your input because I'm trying to force this issue on you. I think we should just all move the x's to the left. Heck with the consequences. So I'm going to subtract 7x because I want my x's in their correct home. I want to place them early. So I'm going to take away 7x. And then on the left side, I'm going to take away the same 7x, giving me -11x. And then who's not welcome? 9 is like, I'll show myself out. And so we have to take away 9 to make the positive 9 go away. And if we take away 9 from an already -6, we get, it's not 15, it's -15, right? Yeah. Yeah, I got this question yesterday. I don't think it was this class. I'm going to put a purple, and I'm going to put a green box around something. I don't have any issues with what order you write that in, as long as the 4x still owns the negative. So like, as long as your negative and your 4x are together, that's fine. And then you all see that this 9 right here, I'm kind of moving my pen there, that 9 is a positive, isn't it? So then the operator, the verb here would have to be +9. What I wrote in green over here and what's in the green box are exactly the same. Good question. Where people run into trouble is if they're half asleep right now and they're like just coming out of their morning daze, and they go, oh, I thought he said I could write it backwards. Where people get in trouble is if they hear that and they just write 9 minus 4x as 4x minus 9. That is not what I said. Subtraction cannot be commuted. Have you guys ever heard of the commutative property? I don't even know if they still teach that. The commutative property says that you can take addition problems and write them backwards. And that's what I did in green. I did not do that in red. Subtraction does not commute. Subtraction cannot be flipped. Like 3 minus 5 and 5 minus 3 are different answers, right? So if you're aware of what you're doing, the order that you put them in, no one cares. Yeah. What's our last step here? Got to divide by a -11. So there's going to be some action happening here. When I divide by -11, I get my x to drop down. I do have to switch my sign. And what will my answer be? Yeah, it's just 15/11ths. And I know it's positive because two negatives when dividing make a positive, right? Any questions there? All right, let's do another one and then we'll count up the survivors again. We're still at 15. That'll be really rad. Impressive. Next problem is really just kind of the same idea. I'm going to combine my like terms and distribute. I just got some stuff to do. So like these x's that I'm pointing to, they can just old school go together. This is not me having to add 8x, right? Some of you really need to hear that. Not a lot of you, but a few of you. This is not me putting a cute little plus 8x underneath it. This is just combining terms. What is negative 8x plus 2x? It is. It's just straight up negative 6x. Remember, we only think opposite when we're moving something across the problem. Now, on the right-hand side, it's not going to go quite as quickly. I need to distribute, and then I'll combine terms. So my first distribution is the negative 3, and that should be negative 3x and plus 33. Good. My second distribution is by a negative 2. That's going to give me minus 6x and minus 14. That's a danger spot right there. That's where people sometimes fall off. Good job. Good job. Now we're going to focus still on the right-hand side because there's a mess over there. So on the left, I keep my negative 6x and my minus 3, and I keep my sign. And then on the right-hand side, I see some x's. And I go, okay, if I just add that one to that one, what do I get? That's it. Just old school. Just add them together. Bless you. Negative 9x. And then I can just old school add my 33 and my minus 14. What do I get? Just like that. Positive 19. So plus 19 for sure. And hey, look, surprise, we're back to where we always get to, right? Variables go that way, numbers go that way. Let's get this done. So I have to add 9x to move him to make this guy, you know, like a woo and fly across to his buddy. We have to plus add 9x, which gives us 3x. Who's not welcome? That negative 3's got to get kicked to the curb, voted off the island. And so we're going to add the 3 to make him go away. What do we get on the other side? Perfecto. And then we divide by 3. You all right there, Kaysen? Is Kaysen okay? Okay. And then when we divide by 3, absolutely nothing exciting happens here. This is just like no meat on the bone at all. 22 cannot divide evenly by 3. There are no negatives in play. This is just boring. So we just write x is less than, well, 22/3. I haven't been graphing, I don't think, have I? Are you guys okay with that? You get the idea. Open circle, closed circle, shade to the, yeah, nothing to it. All right, let's take a count. How many, raise them high, I want to count. How many are still survivors? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We lost 3. It's not bad. We still have 12 survivors. That's impressive, dudes. That's a lot. All right, we're on to the last couple. These last couple, not that you'll be surprised. Can you imagine coming in here tomorrow and saying, I struggle with fractions? My answer to you will be, well, you should have probably thought of that over the last 7 days. So there is still another flex available today. And I can also stay with you after school. If you think you don't know how to do part of this, you've got to advocate for yourself. Look out for yourself. Look out for number 1. In the first problem that I see, I'm not going to try to distribute, right? You're just going to, if you distribute a fraction when you don't have to, you're just spreading the evil. 2 fractions suddenly could become 4. Why do that? So I'm immediately going to attack this because the fractions are on the outside. What am I going to multiply by? 12. If you said 24, you're not wrong. You're just going to have bigger numbers throughout this problem than the rest of us. So it would work. You're just going to have more annoying reducing at the end. So remember, the big mistake here is going to be that we forget to multiply all of the guys. I think I say this every day. We get so wrapped up in killing fractions that we forget the equity of it. Everybody gets hit, even the boring non-fractions. So here we go. First is right here. What do we get? 24x. Good, done. Second one is going to be right here. And this one, you can always use the hook when you're fraction killing because you picked a number that works. So what is 12 times 1 over 6? 2. So I'm going to put my minus, and then I'm going to put the leftover 2. And then the stuff in parentheses, I know that I'm not to mess with it. All right, 2 for 2. The third distribution, or whatever you want to call it, happens here. What's that? Okay, and the final distribution multiplication occurs on this fraction kill, and what do we get? -3, and then we remember not to mess with the parentheses. So step 1, done. And lo and behold, you look at it and go, hey, this is just like the problem above it. Exactly. That's kind of how math tests go. It's like the harder problems really just wind up morphing into versions of the easier ones, right? That's how it goes. Not out of the woods yet. We have to distribute. So the only math that's going to take place in the next minute or so is going to happen inside these purple boxes. Nothing else matters at this point. So I'm going to copy down my 24x, and I'm going to get minus 10x, and I'm going to get plus 2 times 3 is 6. Is less than or equal to. Copy down the 36. Distribute the -3. You get minus 9x and minus 27. And here we are again. Time to combine some like terms. How many x's will we get on the left? Definitely 14 positive x's. So we have 24 here and minus 10 here. And 24 minus 10 is 14. So I have 14 x's sitting beside a little lonely plus 6 is less than or equal to. And on the right-hand side, it's not x's that I put together. These are called constant terms. So my constant 36 and my constant minus 27 add together. What do you get? You get 9. So I'm going to put my -9x first because I feel like it. And then I'm going to do 36 minus 27, positive 9. Yeah, I was just copying down the minus 9x. You're fine. I was just copying it down. It's okay. This really goes back to Alana's question from 6 or 7 minutes ago about the order that I put those in. You can put them in either order. So we good to hear? All right, time to do that thing that we do seemingly, well, every single time. And that is to, let's add 9x to both sides. And I do have a little bit of a bone to pick with a few of you here. If you are going to show your work here, do not do this. It's one of my pet peeves, and it's not just a personal thing. Like, it's mathematically offensive. If you're going to move the 9x and you're going to show it, you are not adding 9, you are adding 9x to both sides. So if you choose to show your work, you should always remember that when you're moving something with an x, you have to include the x, because adding 9 is completely different than adding 9x. They're like not even in the same ballpark, right? So when I add that 9x, I'm left with 23 x's on the left. Who's not welcome? The 6. And so I say, well, I'm going to show you out 6. I'm going to subtract you here to make you go poof. And then in fairness, I'm going to subtract the same version of you over here, because that's what I do. And then I'm going to be left with my sign stays the same, and 9 minus 6 is 3, and I've made it. Okay, be aware here of what you're dividing by what. I'm going to show you a mistake. Don't write down what I'm about to write down because I'm going to mess up, and I'm going to do it on purpose. But I see this sometimes, and I don't see it a lot, but I see this usually in students that just think, I'm there, I'm done. So don't be a ding dong. Think about the division that you're doing. We are dividing 3 by 23. So I don't require that you show the work, but just make sure you do it in the right order. So my answer should be x is no more than 3/23, like that. And that one, I'm assuming you graphed it, would be a circle that's colored in, and your shading would go to the left. Did we lose anyone on that one? Let's count again. I think we were at 12. How many do we have? Raise them high. Proud. I want to see 1, 2, 3, 4, 5, 6. You're still alive? 6, 7, 8, and 9. We lost 3 more. We're down to 9. That's not bad. You guys are kicking some booty. All right, last problem. And then the rest of the hour, you can just work on your notes or ask some questions or whatever. So that is that. Oh, Nelly. What do we do here? Yeah, fact. So this is the worst problem for some of us because there's workarounds, but we learned a couple weeks ago, I don't remember what day it was, but we learned that the workarounds really aren't worth the effort. So I'm just going to roll up my sleeves and say I'm going in. So I'm going to take this -2 and I'm going to distribute him to there and to there. Not scared. And then on the other side, I'm going to take this negative sign. You can think of it as a -1 if you like. And I'm going to distribute him to there and to there. Remember, always be aware of who's not busy this time. So like who's on break, who's on coffee break. Well, the -2/3 of x over here is on break. This -1 is on break. The greater than sign is on break. This lonely 1 is on break. And this -1/2 of x is on break. So we're only focusing here on where the little funny red arrows are, right? All right, let's do this. Let's see if we can nail it perfect. So the first red arrow on the left is the one I know it's what some of us hate the most. What is the answer to the first red arrow on the left? Yeah, and I would accept a couple of different answers. Here's the most, for anyone in this room who's like, I don't want to ask, but this is the step I suck at. This is your go-to. This is your 100% of the time. I mean, 100% of the time this works. Never fails. There's no trick, no hook. This is straight up, old school. I take the number -2 and I write it as a fraction. And then I write it down and I multiply it by its target, which is 3/4. And this is as old school as I can go. I just multiply, pow, straight across the top, and I get -6, pow, straight across the bottom, and I get 4, and I am done. Like, it's over. Now, would I reduce it? Yes. But as far as like, how do I do that step? That is what you do. You old school it. So the answer to that in its best form is -3/2 of x. That's the result of the first red arrow. That is him in his best version of himself. And by the way, you'll be really glad if you reduced that, because in the next step, the fraction killer, if you didn't reduce it, is going to have to be really, really big. Some of you might have figured that out. But if you reduce it, it helps a lot. All right, on to the second red arrow. What a shame if you get the first one right and then you miss this little dingbat. What is that? -6. It's just old school 2 times 3, man, with a negative in there. It's just a 6. All right, let's head over to the other side. This is easy. This is light work over here. I'm just distributing a negative, so I get -1/5 of x and then +3. And there it is, and it's, whew, I made it. So as I assess the landscape now, I say to myself, I know it's probably time I ought to kill some fractions, eh? You see anything else I could do? I could combine some like terms. So if you're into that kind of thing, which I think this is how I did it yesterday, I could take my -2/3 of x and my -3/2 of x and just copy them down. But then these two, I'm going to put a little green box around them. Those two are like, hey, why don't you just put us together? Okay. So you guys make -7. Nice. That's less stuff I have to multiply by. Yeah, the trouble with those crews is that they don't have the same denominator. And if you try to add them together, then we have to have a whole nother lesson on turning the first one into -4/6 of x and the second one into -9/6 of x. And it's like, oh. So the whole idea with this entire last few weeks of class is how do we avoid having to do a lot of fraction work? So generally anything with a fraction, I'm gonna just leave it alone. Like, don't touch it with a 10-foot pole. And then in the next step, we'll go in with our big monster brackets and we'll eliminate all the fractions so we don't ever have to talk about that. Does that make sense? Could I combine them? Yep. I don't want to. I'm going to do the easy. You've heard the expression, take the low-hanging fruit, right? The low-hanging fruit on this side is, look at this little rinker dinker. What's 1 + 3? Let's take it. It's free. It's on the house. Let's just grab it. So we're going to take that 4. And then again, crews, I'm not going to mess with the -1/5 of x and the -1/2 of x. Could I put them together? Yep, I don't want to. Now, if you did not reduce the fraction that says the second fraction on the left side, you would have to fraction kill by 60. I think some of you may have discovered that. But because we've reduced it down, we don't have to go that big. What is our fraction killer for 2s, 3s, and 5s? 30 is our guy. Yep. So this is really the most efficient approach, I would think. Maybe. All right, final step is coming right up. So here we go. We're going to make it. For the first multiplication right here, I know to hook 30 divided by 3 is 10. 10 times the top, -2 is -20. One down, 5 to go. For the second one right here, do the hook again. Take the big number 30 divided by the bottom. What's 30 divided by 2? 15. Grab it and multiply it by the leftover -3. What do you get? No, it's not 45. It's -45. And then stick your X on there. And I'm telling you again, as the guy that sits here with this red pen, I take off lots and lots of points because we are so quick to pat ourselves on the gluteus maximus for doing good fraction killing that we forget that. What is 30 times -7? -210. Don't forget the non-fraction guys. They're like, I'm important too. Is greater than 30 times 4 is 120, right? And then we're going to take 30 all the way across to here. Do your hook. What's 30 divided by 5? 6 times -1 is -6x. And finally, we're going to make it over to here. 30 divided by 2 is 15 times -1 is. We made it. We've emerged from the forest of fraction evil, and now we've got something that the big numbers, who cares? If your math teacher lets you use calculators, big numbers are no different than small numbers. None, not at all. Same. So on the left-hand side, I do see some like terms that I can combine. So I'm going to put my x's together, and I'm going to get how many? -65. X minus 210 is greater than. And on the right side, put these together. What do you get? -21x's. And then copy down your positive in the form of a plus 120. We're there. Knocking on the doorstep. Add 21x. The x is over there, left side. If I add 21x, I'm going to show my work right here. If I add 21x's right here and I add 21x's right here, these x's go kapoof. How many x's am I left with? Yeah. Who's not welcome anymore? Say -210, you're going to have to show yourself out. Here, let me help you show yourself out. So I add 210, go to the other side, and I add 210, cancel those out, and I am there. I'm at the door, ready to knock. Is greater than, what is that? And then this ending is where you really probably want to make sure you take advantage of the fact that you're allowed to use calculators, because this one gets ugly. I'm going to write it in its raw form, and then we'll fix it. It becomes x is, switch the sign, -330 over 44. Now, if you know how to use the fraction function on your calculator, you're going to just type it in, hit enter, and you go, oh, neat. If you don't, then you're going to use the old, what we call chipping away at the stone. You're in high school, so I know you can look at 330 and 44 and say they're both divisible by 2, right? So you start dividing, and then you go, oh, I know that those can both be divided by whatever, and you chip, and chip. It turns out, believe it or not, that these numbers up here on the board can both be divided by 22. Who'd have thunk it, right? And so it's really a good time to embrace the technology. Let your calculator assist you. It's so nice that you could just type in the fraction, hit enter, and you're like, bam, thanks, calculator. You reduced it for me. The final answer on this one should be x is less than -7 over 2. No, that's not correct. Is it? It's not 7 over 2. It's like, what is it? 15 over 2. Good God. What happened to my math teacher? Did he? Yeah, that's my bad. 15/2. Open circle, shade to the left. All right, let's count survivors who made it through all 10 unscathed. 1, 2, 3, 4, and 5. Is that a hand? 5. Not bad. Good job. The numbers indeed dwindled. You better come roll in here tomorrow with, oh, please bring your own calculators. I don't, it's like some of you don't know where Walmart is. Yeah, okay. If you don't, I have them, but please don't let me be your calculator supply all year. That's something you're supposed to buy. Also, make sure you have a page of notes and bring your practice quizzes with you. Practice quizzes. Uh-huh. Yeah, were you gone? Okay.